is a beam of light crossing this channel right here. It's running this way. So if we took, say, a tube of liquid like this. Now this one happens to be quite clear, doesn't it?
Mm-hmm.
All right. Now would you say that a beam of light would pass readily through this because it's clear? Right?
Mm-hmm.
So this machine indicates how well a beam of light transmits through solutions. All right. Now this machine also indicates the inverse of transmission of light. It also indicates the absorbance of light. So this is our zeroing solution for this machine. So I'm going to put this in here like this, and I don't even have to touch it now because I fixed it before. Now, my needle right here on this gauge is reading 100% transmission. That's the top set of numbers. The bottom set of numbers reads absorbance. Another way of expressing absorbance is optical density. So I'm reading 100% transmission of light on the top scale and 0 absorbance on the bottom scale. See, they're inverse of each other. You with me?
Mm-hmm.
All right. So now my machine is 0. Now, let's just say, for example, that this was not clear water but muddy water. And I put it in here. I'm going to be somewhere less than 100% transmission of light.
Mm-hmm.
And I'm going to be absorbing more light because that light beam is refracted by the particles that are in solution. Is that correct?
Mm-hmm.
All right. So you understand the principle. Now, what we're going to do is measure the concentration of cholesterol in a patient. But in order to do that, we've got to have a standard to compare it to, right?
Mm-hmm.
So this tube right here contains a known concentration of cholesterol. We happen to know that the concentration of cholesterol in this tube is 200 milligrams per 100 milliliters.
Is that standard for measurement?
Hmm?
Is that standard when you're doing your measurements?
No, it
You
could
just
be
know.
anything.
Okay.
We could compare it to anything. It just happens to
Okay.
be 200. All right? Now, what we want to know is how does this thing transmit light? Or what's its optical density? We know it's 200 milligrams of 100 per 100 milliliters of cholesterol, but now we're reading down here 34% transmission of light on the top scale, and down at the bottom we're reading 0.48. 0.48 absorbance or optical density. Now that's just a raw number, all right? But remember that 0.48. All right? Now, over here is our patient sample. And we're going to see what the optical density of this solution is right here compared to our standard. You with me?
Mm-hmm.
All right. So let's put this in here. And hello,
I know it.
this is reading 0.98 and optical density or absorbance and 10% transmission of light. All right. So what was our first number?
4.8.
0.48. This is now 0.98.
Mm-hmm.
So what do we know already about the patient's cholesterol
Is it too high?
relative to our standard?
Too high.
It's higher, isn't it?
Mm-hmm.
because the number we just read is significantly higher than the first number we read. So it's a ratio, isn't it? All right, so how are we going to then come up with a number for the concentration of cholesterol in our patient?
Do you just divide one by the other for
No,
percentage?
no. Well, we multiply the ratio times 200%. I mean, 200 milligrams per milliliter.
Okay.
It's on your handout. I should have had you bring your, let me get over here on the board. I should have had you bring your papers up here. But when you work this, you've got a ratio here. 0.98 is the patient. You put that on the top, and down here you put 0.49. All right? Now, times 200 milligrams per 100 milliliters. Well, it just so happens I can do that in my head.
Mm-hmm.
This number is twice this one, isn't it?
Mm-hmm.
So 2 times 200 is
400.
400 out the root for our patient. This is our patient. All right? So it's just a ratio. Now, what if our patient had been the patient would be less than 200, right? You know, you just play with the numbers, but that's how it works. You follow me? So, and you can do this, it doesn't have to be blood, plasma, or serum. You can do it with any solution. But, you know, that's the principle. Okay. So we zeroed our machine. We had a known concentration that we measured the optical density of, and we compared it to our unknown. The patient was the unknown. All right. Now, the normals in humans nowadays, and we'll talk more about this when we get to digestion and nutrition, but cholesterol should be no higher than 200 milligrams per 100 milliliters, and the lower the better, usually. But you don't have to get it so very, very low. In fact, I maintain that it's bad to get your cholesterol too low. You see. That's not what the doctors say. Well, I'm giving you an alternative view, all right, which I'll explain more later. All right? What about cholesterol? I mean, what about LDL?
That has to be higher.
Low density lipoprotein, the so-called bad cholesterol. All right? So what's the top number? Should not be over about 130 milligrams per 100 milliliters. Now, since the turn of the century, they keep cranking that down lower and lower. They're saying now if you're at risk for heart disease, it should be 100 or lower. Or if you're at really high risk, it should be 70, around there. All right? And of course, people have trouble getting their lipoproteins that low, and so they're prescribed cholesterol-lowering drugs. Yeah. All right, what about HDL, the so-called good cholesterol?
Should be a little higher, but I don't know what
Alright.
it is.
Yes, the reason you call it good cholesterol is that it picks up the excess LDL and takes it back to the liver, so it takes it out of circulation. So you want that to be at least 40 milligrams per 100 milliliters, and the higher the better.
What if it goes?
Triglycerides, 150 milligrams per 100 milliliters is the highest it should be, and the lower the better. Okay? And I agree with that. The lower the better for triglycerides too. But cholesterol doesn't need to